Hi Group 5, today we are going to work through the 2015 Paper 1 SQE exam paper. Remember, this is a non-calculator paper. I will, first of all, this is part 1, I will work through approximately the first half of this paper 1, and then you should do the attached questions that follow, and then I will do a separate video, part 2, which finishes the rest of this paper 1, and you will have questions that are similar to it to match. Okay, let's make a wee start. Right, number 1, subtract fractions. Now remember, when whether you add or you subtract fractions, you can only do so if you have a common denominator. The denominators, the ones at the bottom of the fractions, are 5 and 3. They're not the same. They must be changed. They must be the same. Okay? What I would do in this question, and remember, if you think you would do this slightly different, pause the video, do it your way, and just double check you get the right answer, because there can be sometimes a couple of different ways you can do this. Anytime I see these mixed fractions, that's, for example, the 6 and a 5th, mixed fractions, mixed numbers, I would convert them into the top-heavy improper fractions, okay? 5 at the bottom, 6 times 5 is 30, add on the 1 at the top, that there is a 31 over 5. Anytime in a fraction question when I have a fraction like that, 2 1/3 as well, I would convert that as well in exactly the same way, okay? So these are going to be put into thirds. 2 times 3 is 6, add the 1 at the top is 7. Okay, you don't need to show the working to do that conversion. I've shown you, obviously, as I'm going over the division, okay? Right, so really what we've got here is 31 over 5, 31 fifths, subtract 7 thirds. Right, I think it's easier to do this way, okay? We're going to get a common denominator. We need to change the 5 and 3. We're changing them into numbers that 5 and 3 go into. 5 and 3 both go into the number 15. If in any doubt, multiply 5 and 3 together. But 5 and 3 go into 15. We've obviously changed the number on the bottom. We must change the number in the top in the exact same way. How did we get from a 5 to 15? We multiplied it by 3 times the top by 3. 3 31s, 93. On the bottom it was a 3, now it's a 15. We've obviously multiplied that by 5 to go from 3 to 15, so times the 7 by 5 as well. 7 5s, 35. And now that we've got a common denominator, we can get a single fraction. Really what we're doing is basically 93 take away 35. You don't need to write that bit down. You can actually go straight to, well, what is 93 take away 35? Remember, this is non-calculator work. Okay, I don't want to see anyone, not that I will see you, but please don't be picking up your calculators. 93 take away 35 is 58, okay? Let's just double check to see if it says whether we need to write it as a mixed number or anything. It just says evaluate. That answer will get you full marks, okay? Sometimes, if you want, not that we've ever been asked to change it back into mixed numbers, but because this is a top heavy fraction, the bottom being the 15, how many 15s can you get out of 58? 3 15s make 45, and there'd be a wee 13 left over. Okay, either of those two answers, they're both correct. 58 over 15 or 3 and 13 15s. They're both correct and would both be awarded 2 full marks. Okay. Right, number 2, solve the inequality. Right, it's really just do this as if it's an equation, okay? Just pretend that wee less than symbol in there, the wee less than symbol, just pretend it's an equal sign, okay? So we've got 11 take away. Now remember, we're multiplying out this bracket. Think of it as a negative 2 times 1. Negative 2 times 1 is 2. Think of it as a negative 2 times the positive 3x. Negative 2 times a positive 3x would give us a negative 6x. So that's as multiplied out the brackets. Less than 39. Okay, now again, there's a couple of different ways you can approach this question. Some people put their x's on one side, the left. Some people put, it doesn't matter as long as you know what you're doing and you get the right answer. So see if you want to pause it, do your version, see if you get the same. That's absolutely fine. I would maybe tidy this up a wee bit. 11 take away 2, so that's 9 take away 6x. Okay, now just like equations, we get the x's on one side. I would leave the x's on this side. Okay, I'm going to do it this way because this is probably the most common way people would do it. Please be careful. If we move this 9 across, we've got 39, take away 9, which obviously is 30. What have we got on the left-hand side? It's not 6x. This is negative 6x. Okay, so it's negative 6x. That's less than 30. Right? How do we work out what x is? What we're going to be doing here, we're going to be dividing 30 by negative 6. Now be very careful. What happens when you divide by negative 6 in an inequality question? What you actually need to do, and hopefully now that I'm mentioning it just now, you're sitting here thinking, yes, there's something we need to do. We reverse the inequality symbol. X is actually greater than. What's 30 divided by 6? It's 5. 30 divided by negative 6 is negative 5. Okay? Now, we divide by a negative number, we must reverse the inequality symbol. If that was just divide by 6, if it was only 6x, we would not reverse or flip the inequality symbol. It's only because we divided by the negative 6 here. Okay? Because we divided by negative 6, we reverse the inequality or flip the inequality symbol. Okay? Right, number 3. Oh, we love these questions, right? Find angle BDF. Let's just double check we know where angle BDF is first. Okay, I'll read through the information in just a wee minute, but BDF, I'll see if I can put it in, I'll put it in red. BDF, go from B up to D and along to F. So it's the angle that's created, BDF, is that full angle in there? The angle that's made up of 2 smaller angles. Okay, I'm just going to remove that red bit. Right, okay, when you do this question, there's 3 important angle facts that you should have in your head to do this question. Okay, the 3 important angle facts. First, and again, it doesn't matter how the order is not important, but when you have a circle, nope. Right, that's better. Right, if you have a circle where the radius has been drawn and the radius has been drawn again, and it's creating a triangle. If that's the radius and that's the radius, they're both the radius, they're both the same size, they're both the same length because they're the radius, then what that creates is an isosceles triangle, and it means these 2 angles at the bottom are the same. Okay, so that's angle fact number 1. Always look for that as soon as you see a diagram like this. That is what you're looking for. It's not in every single question. You may not have the isosceles triangle. But if you don't have that, we have this other angle fact where if we have, that's a semicircle, it's a diameter. I've cut the circle into half. And there what we have is, we call this one the angle in the semicircle. That angle up there is always 90 degrees, the angle on this edge of the circumference, okay, where the diameter is there. Okay, that's angle fact number 2. Those 2 angle facts, looking at the diagram that we have above, I can see both those angle facts in that picture. And that's the way I would approach these questions. I would think of these angle facts and see if I can apply them and find them in the diagram. I can also see the third angle fact. Third angle fact is what happens when we have what we call a tangent. A tangent is a line, straight line, that just touches the circle at one point. And what happens is, if we have the radius, picture's not great, but it should be easy enough to, clear enough to see what we're talking about here. There's the tangent, the straight black line across the bottom that's just skimming the edge of the circle, and there is the radius. If we have that, we have a right angled triangle. That there is a right angle. Okay? Right, so what I'm going to do is see if I can apply these 3 facts, or as many as I can, to that picture, and I can see that I can apply actually all 3 facts. Right, let's have a wee go. I'm going to go on to the next page to do this, so if you wanted to make a note of the facts, you can have a wee go with that. Right, I've got the picture here, right, there we go. Right, so angle facts, right, let's see, it doesn't matter which order you do this in. Remember, just as a wee reminder, we're trying to work out the size of that red angle between B to D to F, the total. It's likely we're going to have to work out the two separate angles and add them together. Okay, it looks like that's what we're going to have to do here. Right, okay, let's see. Right, there's the tangent. That's 90 degrees. Okay, because it's a tangent and it meets the radius. Now, because that's 90 and we already have one part there that's indicated by 77, the wee black bit in here is the remaining part of 90. 90 take away 77, which is, and remember this is non-calculator, that's 13 degrees. So that wee one in there is 13. Now, I'm going to turn this on the side, right? It might help you. I can see one of the other angle facts that I mentioned a wee minute ago about the isosceles triangle. See if I can try a different colour, although it might just get a wee bit messy. Right, there's the radius, and there's the radius again. Right, those two green lines are the radius of the circle. There's the triangle. So the radius, remember the radius and the radius, no matter where you draw it, they're the same. So, because I've just put this one in here as 13 degrees, I'm going to clear up a wee bit of this just now, okay? Let's see. That is 13, so that's 13 as well. Oh, come on, let me fill it in. Oh, yeah, there we go. Because they're both the radius. Okay, on its side. If you turn that to its side, it might actually be a wee bit clearer. Right, this triangle that's on the right part of the diagram here, this is one of the other angle facts. I think it was angle fact number 2. This is a 90-degree angle because of the angle in the semicircle. Okay, if that's a semicircle and that's the 90-degree angle, then this big triangle here that we've got, DEF, I think it's called, DEF. Well, it's not a great triangle, but anyway, it's a right angle here. We've talked about that one's 13 because that one's 13. To get this wee one here at the top, this is a right angle triangle on the side, so 90 add 64 is 154. Remember, non-calculator. How do I find this one here, the one beside the 13? Well, 3 in a triangle need to add up to 180, so I'm going to take the 154 away from 180, which leaves you 26. Okay, so the one beside the 13 is 26. So the total size of that angle BDF would be 13 and 26, 39 degrees. Okay. Number 4, multiply out the brackets and collect like terms. I'm going to do this one quite quickly. This should be a pretty standard question that you're all familiar with and you should be able to make a good attempt at it yourself. Okay, I shouldn't really be teaching anyone this question, to be honest. We should be fine with this. Right, x times x squared, x cubed. X times a positive x is another x squared. And x times negative 2 is negative 2x. You'll get 1 mark for that. Okay, and now we're going to multiply everything in this second bracket by the negative 4. Negative 4 times x squared. Negative 4x squared. Negative 4 times a positive x is a negative 4x. And negative 4 times a negative 2. Remember, you're multiplying. Negative 4 times negative 2 is a positive 8. Get another mark, second mark, for getting those 3 terms correct. Okay, and your final mark is for collecting your like terms together. There's no more x cubed. There's an x squared. Take away 4x squared. Remember, this plus x squared is a positive 1. There's just one of them. Take away 4. So we've got negative 3x squared. Negative 2x, take away another 4x, together gives you all in total a negative 6x. You're collecting negative 2, add another negative 4 is negative 6. And you're plus 8 at the end. Okay. Number 5, standard deviation is equal to root A. Find the value of A. Right, quite often we have a standard deviation question in paper 2. It usually is paper 2, a calculator question. However, don't be put off that this is paper 1. The numbers have been picked easy enough so it makes it really doable, okay? Basically what they're asking you to work out is, what is the standard deviation? Okay, we done one like this in the last exam paper. Now it doesn't say it, but remember, to find the standard deviation, the way we set it up is we work out this the table with the 3 columns. But to be able to find the standard deviation, you must find the mean first. It doesn't always tell you to work out the mean. Most times it does say part A, find the mean, and part B, find the standard deviation. To find the mean, remember you're adding up all the values. 1, 2, 3, 4, 5. There are 5 values, and we divide it by how many you've got. There's 5 numbers. We're going to divide by 5 here. Okay. Let's see. And remember, it's non-calculator. Again, the numbers are doable. 8 and 2, 10, 15. This makes 15. Divided by 5. What's the mean? The mean is 3. Okay. Standard deviation, as I said, we set up the 3 columns. All the numbers that you have in the question are written down the left-hand side. The middle column, I call it the difference column. Right? Remember it with the letter D. It's the difference between each value and the mean, which is 3. Right, the first number is 1. What's the difference between 1 and 3? It's 2. What's the difference between 2 and 3? 1. What's the difference between 2 and 3? 1. And a 1 again. What's the difference between 8 and 3? 5. Third column, we call this the difference squared, d squared. Use that d squared to help you remember what it is. The differences get squared in this column. 2 times 2, squared 2 is 4. 1 times 1 is not 2. 1 squared is 1. It's an easy mistake that I don't know how many people make. 5 squared, difference is 5. 5 squared is 25. Okay, we're nearly there. We total up the differences. 25, 26, 27, 28, 32. Almost there. The mean, remember, the standard deviation, we now do the total divided by 1 less than how many you've got. We're not dividing by 5, we're dividing by 4. And you can see that it's doable without a calculator. 32 divided by 4 is 8. Okay, if I was doing this question in a non-calculator exam paper and I was getting numbers that were totally not doable, see if that was 32 divided by 7, you'd be like, right, okay, there's something not quite right here, okay? If this comes up in paper 1, it's because the numbers are totally workable. Right, but we're not finished. What's the last step of the standard deviation? It's the square root of that number, root 8. So let's just check. The standard deviation is equal to root A. Yep. That's it. It looks like root A. Find the value of A. If you just do that and don't write anything else, you've got full marks. Okay, you've done the question. But the answer is, what is A? Well, it's root A. A's 8. Okay, but you'll get full marks for writing that. Okay. Number 6. Part of the graph is A sine bx. It's shown in the diagram. What is A? What is B? Right. Okay. Y equals, when we have an equation like this, your first value is to do with the amplitude. The amplitude is to do with this bit here. Okay, it's gone up to 4 and it's gone down to -4. So A is simply 4. Okay, because of these values here. If it was gone up to 2 and down to -2, A would be 2. Okay, this is a sine graph. The basic sine graph goes like that. It goes up to 1 and it goes down to -1 and it ends at 360. That there is the basic sine graph. Okay, that's not what I meant to write. Come on. Right. That's the basic sine graph. It goes up to 1, down to -1, and it ends at 360. Right, this one's gone up to 4 and down to -4. That's why we've got a number 4 at the front. What this B is to do with, okay, this B, you'll notice the normal sine graph ends at 360, as I've shown down below. Okay, the graph does end at 360, but we've actually got 1, 2, 3. There are 3, we can call it 3 waves of the sine graph. Okay, the first sine graph, there's 1. The second sine graph, there's another 1. And the third sine graph, there's 3. So there are 3 sine graphs ending at 360. That means B is actually 3. Okay. Next one, number 7. Here we have a parabola. The minimum turning point is 2, -4. And find the values of A and B. Okay, right. Normal parabola. That's basically what x squared looks like. This one's been shifted a wee bit. Okay, the one that we've been given in this picture, the coordinate is 2. That means the coordinate of that turning point is along there at number 2. Okay, and then see the next number in your coordinate is -4. That means it's down to -4. It's 2 along and -4 down the way. That tells you these values in the equation. Okay, right, so the A value comes from the first number. Okay, this has been moved along to 2. Right, it doesn't start at 0 anymore. It's moving along to 2, and I'm hoping you're thinking yourself, you know the answer. I'm working through it slowly so that you're hopefully it's sounding familiar. A is actually not 2, right? It's something to do with 2, right? That is +2, but A is actually -2. Okay. B value. It's how much it's been shifted down, right? It was sitting at 0, it's been shifted down to -4. B is -4. Okay, and part B, what is the equation of the axis of symmetry? The line of symmetry, I'm going to rub off a wee bit here. The line of symmetry, all these parabolas are symmetrical down the middle. Okay, there's a line of symmetry if I wanted to draw it on. The equation of a line of symmetry is not a number. An equation has an equal sign in it. So part B, it's got an equal sign in it. If you were just thinking of a number in your head, good, but the equation of a line of symmetry has to have an equal sign in it, okay? What number is this on the x-axis? What number is that? We've already talked about it. That turning point is 2 along. That number there is 2. What number's 2? Is it x that's 2 or is it y that's 2? Well, it's number 2 on the x-axis. The equation is simply x equals 2. That is it. Okay? Right, that's part 1. Part 2, please first of all do your questions that have been provided, and they're a bit similar to these ones here, and then you should go on to watch part 2 and then do the questions to match. Right, good luck. Mind I'm always here. Ask for help.